Alright, experiments. So everything I've described so far has been an observational study, where you go and you take a look at what there is out there, and you go, this is what I found. Experiments in statistics refers to something very different. So let's start off with a few questions. Does sport participation improve student grades? Does college make people earn more money? And if so, how much? And does eating ice cream increase risk of drowning? So let's look at all of these from the perspective of a study. How would you do a study on each of these? Well, for a study, you would get a random sample of students who participate in sports, a random sample of students who don't participate in sports. You'd find a GPA average among these, you'd find the GPA average among those, and you'd see if there's a difference. And you would say, sports improves your educational attainment. I'm pretty confident that if you did that study at Joseph Case, that's what you would find. You would find that students with higher grades tend to be, well, I should take it around. Students who participate in sports tend to have higher grades. And others of you who aren't into sports might say, hold on, that doesn't make any sense. Like, wouldn't that waste your time? And we'll get to that in a second. Second, does college make people earn more money? If so, how much? Well, you grab a whole bunch of college graduates out there in the United States, you find their average income, you compare it to some others, didn't go to college, and you find people who went to college and made more money, aha! You know, those would be observational studies, and you know, if you did an observational study on ice cream and drowning, you studied a bunch of communities where more ice cream is eaten and a different bunch of communities where less ice cream is eaten, you would find that drowning happens more often in communities where more ice cream is eaten. And this might alarm you, and then you would say, whoa, you know, it looks like ice cream causes drowning. But if you say that, you're making the same mistake in all three studies, and that is, you're thinking that because there's a link between two things, that it's a causal link. In other words, that one creates the other. When a study can't measure cause and effect, you're just seeing if those two things happen in the same place, not if one causes the other. Let me go over these one by one so you'll see what's going on here. We think, if we do a study, that maybe sports participation causes grades to go up. That maybe sports participation leads to grades. But that's not necessarily true. What we do know is that if your grades are bad, you become ineligible in Swansea. And so maybe it's really grades that creates sports participation, and not sports participation that causes grades. Really what we have is we have a third variable here, eligibility, which has a relationship with both grades and sports participation. And so we would say that eligibility is sort of getting in the way here of us doing a study. So similarly, we think that college makes people earn more money, but maybe it's actually like family background and intelligence a whole bunch of different things that could actually cause the more money, and the college could be related to that. It might not actually be college creating more money at all. So you grab some random person, you send them to college, it might be that won't increase their income. It's actually these things that does. We don't know. So let's take a look at this also. Yes, towns where more ice cream and times when more ice cream is eaten, when ice cream sales go up, so do drowning deaths. And this is because both of those things are related to temperature. Summer months, sunny locations and outdoorsiness. Florida, there's going to be more ice cream sold than Maine. And yes, more people are going to go outside and swim in Florida than in Maine, whether it's in a pool or whether it's in the ocean. So observational studies can sometimes make links appear that aren't really there and miss things that are actually there. And so let's talk about different variables here. Okay, different variables. There's anything we basically can measure. It can be numeric, like grades, sort of, and more money, or it can be non-numeric, like, well, we'll get into that later. That's chapter 1 stuff. Anything you can measure, yeses or nos or numbers, is a variable. So in the first example, we thought let's talk about explanatory and response variables. Explanatory is basically the x, the cause, and response is the effect, the y variable. If you're thinking x and y, you would always plot the explanatory on the x value and the response variable on the y axis. Because you want to see, as we increase the explanatory variable, how does that affect the response variable? As I increase someone's sports participation, make them participate in sports, how does that change their resulting grades? Or maybe it's the other way around. As I change somebody's grades, does it make them more likely to want to participate in sports? I don't know, maybe. But then you have confounding variables, which are variables which have a relationship with both what we think is the explanatory and what we think is the response variable, muddying the waters. So in this case, intelligence and community expectations is a confounding variable. In this case, temperature is a confounding variable. Another variable that's linked to the other two that's going to confuse the signal with the noise. Confuse true relationships with just random, with other things. So let's talk about what experiments do differently from observational studies. Experiments do their best to isolate these variables and set them aside out of reach where they can have an effect. You do this by imposing treatments. So let's talk about that. I grab a sample of people. We're not going to talk about samples right now. I grab a sample of 50 students from Joseph Case. And I get special dispensation from Mr. McCann to experiment here for a bit. I get 50 random students from Joseph Case, and I take 25 of them, and I tell them, I randomly select 25 of them, and I tell those 25, you must participate in a sport this fall, at least every other day, whether you want to or not. Otherwise, you're being expelled. I don't know. And I grab the other 25 and I tell them, you must not participate in any sports or get any serious amount of exercise for the next 3 months. And then I take a look at whether there's any change in their grades, whether their grades get better or worse, whether their grades are better or worse to begin with. But the point here is that I impose treatments, the treatment in this case being told to do sports or told not to do sports. Treatment in medical science can involve, here take this medication, here take this other medication, here take no medication, to see if there's a difference. In this example, what I might do to see if college actually creates more earnings is I might grab 50 people, have them all agree to participate in this experiment beforehand, and then tell 25, we're sending you to college, and tell the other 25, we're not sending you to college, you can't go to college. And then see if they make any money 50 years later. And this actually brings up a couple of interesting points, because I bet you never thought of it that way, of saying, oh, hold on a minute, maybe it isn't actually college that makes people earn more money. Because nobody can ethically, and it takes way too much time and effort, and I don't know if you could actually manage to force people to not go to college who want to. That study's never been done. So there may be confounding variables in everybody's assumptions that college leads to more income. I don't know. Nobody knows. We can assume things are true because they seem true and there's a lot of evidence for them, like college earning people more money. but no one's ever done that experiment, and so cause and effect cannot be established without an experiment. Similarly for smoking, nobody has sat down and forced like 500 people to smoke 2 packs a day for years and years and years, and forced other people to not smoke cigarettes. And so there's never been a study establishing in that way that smoking, now there's a lot of evidence for it in other ways. They can do that to mice and see the cancer rates, but no one's actually done it on people. Similarly with ice cream and drowning, you can't force people to eat ice cream and then force other people to not eat the ice cream, and like do this on a large enough scale that you'll be able to notice, drowning differences. Like you make 100 people eat ice cream, make 100 people not eat ice cream. It's most likely that none of the 200 people are going to drown. You'd have to do this on such a large scale that that would be worth the time and the money. What I have to say about experiments is basically that this next chapter is all about how to create an experiment in a proper way so that we can judge cause and effect, which we cannot do with the observational studies we've looked at so far.